Hello viewers, my name is Mr. Kazim and I am delighted to welcome you to my YouTube channel at Smart Edu TV. Here, you will find detailed tutorials on your science courses and tips on how to answer examination questions successfully. I started this channel to also share my knowledge and experience in this field and to give you tips on how to succeed as a university student. If you are looking for detailed tutorials on physics subjects, chemistry, mathematics, biology, statistics, and general studies (GST), then you have come to the right channel. So therefore, sit back, relax, and join me on this journey. Don't forget to hit the subscribe button and turn on the notification bell to never miss on an important update. Please remember to also share this video so that others can benefit. Thank you very much.
Okay, the charge to mass ratio of an electron is 1.759 times 10 raised to power 11 coulomb per kilogram. From this one and this value, we can eventually find the mass of an electron, which we know to be 9.1 times 10 raised to minus 31 kilogram. So the second contribution of J.J. Thomson is the determination of charge to mass ratio of an electron, from where we can eventually find the mass of an electron. Lastly, the third contribution is what we call Plum-Pudding model. So Thomson was trying to explain how the subatomic particles of an atom are constituted in an atom. Having known that an atom possesses electrons which are negatively charged. So I've shown 6 negative charges here. Since an atom is proved to be electrically neutral, it means that there must be 6 positive charges as well. So according to the J.J. Thomson's Plum-Pudding model, it says that the electrons are embedded together in an atom with the protons. So this is what the model of an atomic structure look like using the Plum-Pudding model. So these are the 3 contributions. Then before we leave the J.J. Thomson model, let's look at the limitation. We are not looking at the limitation in the first one, which is the discovery of electron. We are not looking at the limitation in the second one, which is the determination of charge to mass ratio. Rather, we are looking at the limitation on the Plum-Pudding model. Of course, when we learned about structure of an atom in the past, you never did something like this. You learned that the protons are at the center while the electrons are revolving around it. So for us to have them scattered in this way, according to Plum-Pudding model, is not the way the structure of an atom is. So what is the limitation? The limitation is that the atoms, the protons and the electrons are not in this form. What form? We are going to look at that in another concept. So thank you. The first postulate, John Dalton said an atom is the smallest particle of the substance. So remember the word smallest. Number 2, atom can neither be created nor destroyed. So number 3, atoms of the same element look alike in all aspects. Number 4, atoms of different elements do not look alike. And number 5, atoms combine in smallest whole number. So there are 5 points we can get from the postulate of John Dalton on the structure of an atom. But why we are fast on this is that perhaps you might have heard of these postulates before. Today we want to look at how these postulates or some of these points are no more valid. So number one, we say atom is the smallest particle. But it was later found out that atoms still consist of subatomic particles. So if something is smallest, nothing should be smaller than that thing. So if an atom is going to be the smallest, it shouldn't contain what we can call subatomic particles. Example of these subatomic particles are protons, neutrons, and electrons. So in other words, the existence of protons, neutrons, and electrons invalidates the statement that atom is the smallest particle. Number two, atoms can be destroyed in processes we call nuclear fission. Likewise, atoms can be created in processes we call nuclear fission. For example, let's look at uranium. Uranium can be split into two, which is thorium and helium. In this case, we are able to see this is actually a radioactive disintegration in which the atom we know as uranium is no more existing as uranium, but it is now thorium as well as helium. So the atom uranium has been destroyed, while atom thorium and as well as atom helium have been formed. So processes like this they invalidate postulate of John Dalton. Then the other one that says atoms combine in smallest whole number. So such as when we have water, we have CO2. So let's look at the ratio. You can say hydrogen combines with oxygen in the ratio 2:1. Likewise, in carbon dioxide, we see it as ratio 1:2 between carbon and oxygen. But while these ones are trying to attest to the postulate of John Dalton, there are some other compounds in which the ratio is not in the smallest form. For example, let's look at benzene. You can see that benzene is having ratio 6:6. And this ratio 6:6 is not the simplest. What of ethanol? So, for this benzene, the smaller ratio is still 3:3, another one is 2:2, another one is 1:1. So we can see that the ratio 6:6 for carbon and hydrogen could have been reduced further. So in this case, this one is invalidating the postulate of John Dalton. Lastly, which is where we want to actually go to as far as some of the concepts that invalidate the postulate of John Dalton, is the one that says atoms of the same element look alike, and which extended to atoms of different elements do not look alike. Look at it. An atom has some properties which were later known. What are they? We have what are called proton number, in other words, atomic number, representing the number of protons. We have neutron number. We have mass number, which represent both protons and neutrons. So, for example, if we have sodium, in this case, the sodium atom has 11 protons. The mass number is 23, and the neutron number is 12. An atom has these properties. Let's now compare different atoms and be able to see whether all the time we compare atoms of the same elements. 22. So, okay, I'm doing that. So when we find the difference between the two, so from here, this describes the properties of an atom. And we are going to look at different atoms of the same element or of different elements. If there is a way we can connect this atomic number, neutron number, and mass number to two or more atoms. The first concept that invalidates John Dalton on this one is what is called isotopy. And the atoms that exhibit this phenomenon are called isotopes. So by definition, isotopes are atoms of the same element having different mass numbers. Atoms of same element, for example, hydrogen. Same element means that they have same atomic number, but different mass number. You can see we have three atoms of the element hydrogen exhibiting different mass numbers. Contrary to Jordan says, atoms of the same element look alike in all aspects. So these ones do not look alike in all aspects, at least in their mass numbers. We can see that they have different mass numbers, even though they have same atomic number. So they are called isotopes. So the concept of isotopy invalidates Jordan's postulates on atomic structure. Aside this one, we have some other isotopes. Let us list them and we see. For the hydrogen, we have, for the carbon, for nitrogen, for oxygen, for chlorine. Let's see what we have in them. Carbon, the hydrogen, and the chlorine. Well, we are used to the chlorine, but let's just look at these ones. So the mass numbers here are these. The mass numbers so we can see that atoms of the same element have different mass numbers. Atoms of the same element here, likewise the other ones. So each of them is a set of isotopes. Well, the other one is when we are talking about isobars. Isobars means atoms of different elements that have the same mass numbers, different elements. So let's look at different elements that have the same mass number. We can quickly see carbon 14 and nitrogen 14. So they are isobars. So atoms of different elements, unlike John Dalton's postulate that says atoms of different elements do not look alike. These atoms, they have the same mass number. Finally, we have what are called isotones. Isotones are atoms of different elements but with the same neutron number. The other time we saw how we could get neutron number by subtracting the atomic number from the mass number. So if I want to get the neutron number, for example, in this one, I'll just say 12 minus 6 and it will be 6. Now let's look at different atoms that have different same neutron number. For example, let's find the neutron number here. The neutron number here will be 7, while the neutron number here will be 8. In this one, the neutron number is 7, while the neutron number is 8. Likewise here, the neutron number is 8. So, which different elements have the same neutron number? We can see that carbon 14, nitrogen 15, and oxygen 16 have same neutron number, yet they belong to the same different elements. So they are called isotopes. Likewise, you will also notice carbon 13 and nitrogen 14 having neutron number 7, yet they are of different elements. So carbon 13 and nitrogen 14 are isotopes. Likewise, carbon 14, nitrogen 15, and oxygen 16 are also isotopes. So, isotopes, isobars, and isotones are three concepts that invalidate the postulates of John Dalton. So, when you see them in the exam, or whenever you are reading further, so you'll be able to see that we have postulates of John Dalton and how these postulates have been invalidated in one way or the other. So, thank you.